This is our second example of doing the roots. So we have another polynomial, fourth degree, and we want to find all of the roots. So this is a fourth degree polynomial. We're going to have exactly 4 roots. So we're going to go ahead and use our graphing calculator. And we type the polynomial into the graphing calculator. And then what we get, something like this. And it looks like we have an x-intercept at -5 and +1. So these are going to be possible real roots. And what we want to do is do synthetic division to verify that it is. So we set up our box. We have x to the 4th, x to the 3rd, x squared, x, and constant. Then we put our coefficients in, 1, 4, -1, 16, and -20. Now I get to choose. You can either choose to start with -5 or +1. I'm just going to start with -5. So as a factor, it would be x minus -5 or x plus 5. And now we do our synthetic division. We bring down the 1. We multiply. Add the column. Multiply. Add the column. Multiply. Add the column. Multiply. Add the column. Notice that our remainder is 0. That's what we need. So this is a 0 of the function, and as a factor it's x plus 5. So now what we do is we drop the degree by 1, and this is now our quotient. And we create our box. We bring down our coefficients of our quotient, and we do our other 0 of which is 1. As a factor, it's x minus 1. We do our synthetic division. And notice again, our remainder is 0. So this is a root. So our quotient that's left, we drop the degree again, x squared, x, and constant. So this is our quotient. So in factored form, we have f of x equals x plus 5, so that's that first factor that we divided out. We factored out the x minus 1, that was the second factor. And then what's left is 1x squared plus 4. So now it's in factored form. To find our last 2 roots, we work with our quotient of x squared plus 4, and we solve it for x. So we subtract 4 from both sides. We get x squared equals -4. And then we square root both sides. And we get x equals plus or minus 2i. So these are 2 complex roots. They are complex conjugates. So the 4 roots, the first root was -5 is real. The second root, +1, is real. And then we have our 2 complex roots, +2i and -2i.